any location. But you know, typically you start at zero and go from there. At least for the first one, for regular sine of x. Okay. Now here's another question for you. All right. Well, what about the x? We asked about the x-axis. That is, what x values? When does it start to repeat with those x values? I guess, or what x values does it start to repeat the y values? Maybe. Okay. We kind of asked that. We're going to think about that some. But what about the y values? What's the highest value that we've ever seen sine of b? What's like the highest value for sine that we've seen? What's the biggest value for sine? It's like sine of an angle, right? We take sine of an angle and we get the ratio, right? That ratio, what's the biggest value we've ever seen that equal? 1. Right, yeah, 1. And so it turns out, yeah, 1 is the highest value here. So we only have to go up to 1 on the y-axis. Okay? And what's the lowest value that we've ever seen sine of an angle equal? What's the lowest value you've ever seen? -1, right? Yeah, -1. That's the lowest we ever go. Yep, -1. So we only have to go for a regular, graph of sine. We only need to go between -1 and 1. Okay, we only have to go between -1 and 1 here. All right. So let's just kind of get things started here. So let's start with the with 0, right? Let's start at the origin there. So what 0 on the x-axis there. So if our x value is 0, then sine of 0 would be equal to what? What is sine of 0? Sine of 0, well, let's think here. On the unit circle, okay, on that unit circle there, 0 degrees, we're right here at this point on our unit circle. The coordinate of that point is 1, 0, right? So what is sine of 0 degrees? 0. So sine of 0 is 0, so put that point right there. Okay. And so I guess I should step back here 1 second and also kind of clarify, right? Because in a way, we look at the unit circle and we may think, oh, the unit circle, that is the graph of sine. But we got to be careful, okay? The unit circle is really, it's determined by an angle, right? And an angle, and then the x-coordinate is the cosine at that angle, and the y-coordinate turns out to be the sine at that angle, okay? Whereas here, okay, our x value, the thing we're plugging in, is the angle still, but then the y value is just whatever that sine of that thing might be. Okay, so it's matching the angle from the unit circle, and this in case, again, since we're graphing y, or bless you, sorry, since we're graphing the sine of x, it's matching the angle to the y coordinate here, basically, is what we're doing. Okay, so 0, 0 is our first point. All right, the next angle we come to, right, the next angle we know from our reference triangle and unit circle here is pi over 6. Okay, what is sine of pi over 6? 1/2. Okay, so let's see here. So we're going to have to go, I don't know, I'm just going to pick some arbitrary kind of amount here. So we'll just say there's pi over 6. Okay, and so 1/2. Well, that's pretty easy to graph. We can kind of plot a point like right there, maybe. Okay. All right, and then the next one we come across after pi over 6 is going to be pi over 4. So again, I'm going to put pi over 4, I don't know, like right here, we'll say. Okay. Bless you. And then what is sine of pi over 4? Sine of pi over 4, what's that? Root 2 over 2, very good. And so root 2 divided by 2 as a decimal is about 0.71. So we're going to go a little bit higher still, right? It's not quite 3/4, right? 0.75 would be 3/4. So I don't know, pi over 4, it's going to be something like, maybe right here. All right. Next after pi over 4 is pi over 3. Okay. What's sine of pi over 3? Root 3 over 2, and as a decimal, okay, that's about 0.866, so like a little bit higher still, but not quite 1. And then finally we get to pi over 2. Okay, and what's sine of pi over 2? 1. Yeah, okay. So you go all the way up to that 1 there. And then we move into the second quadrant, right, where we have 2 pi over 3, we have 3 pi over 4, and we have 5 pi over 6. Okay? 2 pi over 3, though, right, its reference angle is pi over 3. And since we're in the second quadrant, sine will still be positive, right? So both in the first quadrant and the second quadrant, sine's positive. So sine of pi over 3 will be the same exact value as sine of 2 pi over 3. And so we can just kind of use some symmetry here, okay, and kind of roughly, you know, kind of, oh goodness, I hope there we go. Okay, like that. So just using some symmetry to help us out there. That gives us 5 pi over 6, and then we got 0, or sorry, not 0, we got pi, and again, pi would take us back down to 0. Okay, and so you can see that kind of wave starting to form there. I think I'm going to run out of space now that I see how far. I don't think I drew my x-axis long enough for all the stuff in there. Okay. And so then for the remaining vertices here, so let's see here, I'm going to go out, so if that was pi, then this will be 2 pi right here. Yeah, I'm going to run out of space, that's okay though. And I'll put 3 pi over 2 right in here. Okay. By similar kind of like plugging in and evaluating and stuff like that, we'll be able to get the rest of the graph here. But let's kind of get some bigger picture points here. So for example, 3 pi over 2, we'll just skip to 3 pi over 2. What is sine of 3 pi over 2? It's going to be negative 1. And then what will be sine of 2 pi? 0, because we're back at the 0 there. Okay, so if you look here, this is what we get. You get this. Curve right there. And again, if we evaluate all the points between pi and 3 pi over 2, so if we did like, 7 pi over 6, and then 5 pi over 4, and then 4 pi over 3, we would end up with a similar kind of negative arch, or negative wave, part of the wave there. And then again, from 3 pi over 2 to 2 pi, it would just be symmetric, and there it is. Okay. So how many full periods have we shown of the wave right here? 1, right? Because it goes up, back down, and starts to come back up to then repeat itself. So here is 1 full period. So 1 full period of the sine of x is what length? What's the length of a period for sine of x? It's a length of 2 pi. It starts at 0, goes to 2 pi, so it's length. It repeats itself every 2 pi, which shouldn't really surprise us, right? We have that idea of like coterminal angles and things, right, where you just you can keep adding 2 pi or subtracting 2 pi to get angles that are in the same position. And so there it is. Okay, there's 1 full period. So actually, we're just going to, because I ran out of space, I'll just change this because it's easier than just extending things. So we'll just show 1 full period. Okay, just easier for ourselves there. So there's 1 full period of sine. And of course, this thing doesn't stop here. It's going to continue forever there. Okay. But of course, that's a lot to graph, right? We just did like a bunch of little calculations here to come up with that curve. And we're not going to do that every single time. I'll show you what we're going to do every single time here, or I'll show you what I would like you all to do in this next one when we do cosine of x. Okay, again, we'll just do 1 full period to spare ourselves. Okay, so I'll do the same kind of thing here with cosine. Set it up in a very similar way. What's the greatest value of cosine that we've ever had? Yeah, 1 as well, right? And what's the lowest value for cosine? Yeah, negative 1. So we just have to worry about going up to 1, negative 1 on our y-axis. Okay, again, we'll start at 0. Okay. So, as it turns out, right, cosine also has a full period from 0 to 2 pi. So what I'm going to have you guys do, okay, from kind of to help you graph these things, is to graph your starting point, 0. Then we're going to graph out to the ending point of the full period, so to 2 pi. I'm going to kind of roughly keep these in the same kind of distance as the early one. So we're going to graph our starting point, our stopping point for a period. So it starts at 0, goes up to 2 pi. We're going to graph the midpoint. Okay, so what's the midpoint between 0 and 2 pi? just pi, right? Very good. Okay. And we're also going to graph our like midpoint of the midpoint, or like our quarter points, if you want to get it that way, our quarter points. So for example, what's midway between 0 and pi? Pi over 2. And what's midway between pi and 2 pi? Ooh, this is harder math, right? Or it's a little bit trickier. 3 pi over 2, right. Remember, to find the midpoint between any two numbers, you just add them together and divide by 2. So pi plus 2 pi is 3 pi divided by 2, 3 pi over 2. There it is. Okay? And all we're going to do now is evaluate cosine at these 5 points, and then just kind of connect the dots, using, and make it nice and, curvy, wavy through there. Okay? So for example, we'll start at 0. What is cosine of 0? 1. Okay, cosine of pi over 2? 0. Cosine of pi? -1. Cosine 3 pi over 2? 0. And cosine of 2 pi? Back to 1. Okay? And so then we can just connect those dots. Okay, so then you can, I also put little dotted lines there, so they'll keep going, right? It doesn't just stop. So there it is. Okay, the graph of cosine. You'll see it looks similar to sine, but it's not the same. Okay, it's not the same. Right? It's not the same thing in the same positions, except at pi over 4, right? Pi over 4, for example, some of these values. So they do intersect. Okay? Questions on any of that? So that's the basic graphs. Those are the basic graphs, I'll say, sorry. Okay? And so then how can we manipulate these things? Well, today we're going to concern ourselves with 2 kinds of manipulations. Okay, the first one we're going to look at is amplitude. Okay, that is the peaks and valleys of our waves. Okay, the peaks and valleys. Right now, okay, we say the amplitude of cosine, the amplitude of sine is 1. Okay, it's 1. It's a distance from the center. Okay, distance from the center. Shoot, there is a name for the distance from the valley to the peak, but I forget what it's called. I can't remember now. Anyway, amplitude, though, is from the center to the peak, or the center to the valley. And so that is governed by the coefficient of sine or cosine. Okay? The coefficient of sine or cosine. Okay? When describing amplitude, we always make a positive. Okay? Since amplitude is like a measure, right, we always make a positive. So for example, if it happened to be like y equals -2 times the sine of x, we would say it's just 2 is the amplitude. Now, what does that negative do, though? If it was a -2 sine x, what does that negative still do? It still does something to the graph. What does it do? Yeah, it reflects it over the what? X-axis, right? Just like any other time you put a negative number in front of, or a negative number in front of your, function, reflecting over the x-axis, same thing happens here too. It does reflect over the x-axis. Okay? So that's the amplitude there. So as a quick example here, we'll look at like y equals 2 times the sine of x. Okay? So again, when you go up, going to be thinking about how you're going to graph your x and y, what you need to have on your x and y axis. Okay? And let's do one full period. Okay? So to graph one full period, that means I'm going to start at 0, and how far out do I need to go on the x-axis? Does amplitude affect the period length of sine or cosine? The answer is does not. Okay, so how far out do we need to go? 2 pi. That's all we got to go out to is 2 pi. Okay, I'm going to do my halfway point, pi. I'm going to do my quarter points, pi over 2 and 3 pi over 2. Okay. On our y-axis, what is the highest that we need to go? What's the highest now going to be for our graph? 2, right? Because sine, the highest it will be is 1, but then we'll multiply by 2, so the highest is going to go is to 2. And then the lowest, the lowest sine will be is -1, but it's times 2, so it'll be -2 then. Okay? And so we'll graph this. Right now, it's going to be the same kind of idea. So again, we just plug in 0. So sine of 0 is 0 times 2 is still be 0. Okay. Now at pi over 2, though, sine of pi over 2 is 1 times 2 is going to give us 2. Okay. Sine of pi is 0, so times 2 will still be 0. Sine of 3 pi over 2 is -1, but then times 2 will be -2. And then sine of 2 pi, 0, times 2 will still be 0. And so there's our graph. Okay. Just like that. And again, it kind of can continue there if you want to kind of show some dotted lines or something like that. Just to sort of continue. Okay. Doesn't look much different than the one we just did, but that's because, you know, I drew it on 2 different kind of scales there with the thing. So if I were to graph this using my graphing calculator here, you can get a better idea. Okay. Let me show you. So there's sine of x and 2 sine of x. I'll make 2 sine of x the thicker line there. We'll graph that. Okay, so there's the original sine graph between -1 and 1. And then there's the amplitude 2. Okay. If I do zoom, there is a nice zoom. You can use zoom trig. Makes it a little bit nicer. It makes the x-axis count by pi over 2s, I think. But there you can see the difference, right? It's twice as big. Still the same period, just it goes twice as high and twice as low. Okay. So there it is, compares. Okay, there it is comparatively. All right. Questions on anything so far? All right, I got one more little transformation I want to show you then, and then we'll be done. Okay. So one other transformation we're going to look at today, the last one we'll look at today, is also adjusting the period. So we're adjusting the amplitude, right? How heights and the lows, right? But now we're also going to talk about adjusting the period. Okay. Your book in Algebra 2 would have called this like a horizontal stretch or shrink, I think. So. Okay, so it's going to be the b here that's in charge of that, where I put that coefficient. Okay, and again, it's sine of the quantity bx, or cosine of the quantity bx there. Okay, and the b and the x are both inside the sine or cosine there. All right. And there are different ways to consider this here, but the way that I'm going to kind of show us, I think that's most helpful to adjust this, okay, is to take a normal period from 0 to 2 pi, and then to adjust, right, so a normal period for both sine and cosine starts at 0, goes to up to 2 pi, and then repeats after that. Instead of that, we're going to go just between, we're going to do the 0 to 2 pi, but we have to adjust for that bx. Okay, and so what we're going to do here is put that bx between the 0 and 2 pi and make it like a compound inequality here. Okay, and by solving this compound inequality for x, which would be dividing both sides by b, okay, this will then show us how our period kind of adjusts, right? So we're still going to start at 0, but then based on that b coefficient, we're going to take that 2 pi and divide it by b. And that's going to adjust our period. So for example, if b is like 2, right, our period will only go from 0 to pi. It'll shrink it, right? If b is like a fraction, like 1/2, it'll actually stretch our period there. Okay? So for example, let's try graphing, y equals the sine of x over 2. Okay, so we'll graph just y equals the sine of x over 2. Okay. Well, when I go to graph that, let's see here. We can see here, right? We're going to have some sort of period adjustment. So I'll take the 0 less than or equal to x over 2 less than or equal to 2 pi. Okay, we're going to put this between there, the 0 and 2 pi, and then we'll just multiply everything by 2 to get the x by itself. Okay. So x is between 0 and 4 pi there. So instead of our period going from 0 to 2 pi for this particular graph, all right, we're going to have to go from 0 all the way out to 4 pi. All right, so again, we go to draw our axes. Okay. I'm going to start at 0 again on the x-axis, but now I'm going to go out to 4 pi. So, I don't know, maybe I'll say, I'll just put 4 pi out here. So there's our starting point, 0. Our stopping point is now 4 pi. And then we do the same thing. Find the midpoint. So what's the midpoint from 0 to 4 pi? Yeah, 2 pi. That's pretty easy, right? Not too shabby. And then what about the midpoint between 0 and 2 pi? Pi. And how about 2 pi, 4 pi? 3 pi. Yeah, that makes it a little bit easier when you have the period b 4 pi like that. Okay. And what's the amplitude of this graph going to be? What's the amplitude? There's no number in front, but what will we say it is, though? 1, right? It's just 1. Yeah, so it's going to go up to 1, down to -1. So there's no amplitude here. Okay. Of course, we will mix those things in together at some points. All right, and we do the same thing we do in the past. You just take turns plugging in each one of these 5 points. So 0 in for x. 0 divided by 2, 0. Sine of 0 is 0. Okay. Pi. Plug in pi. Pi divided by 2, pi over 2. Sine of pi over 2, 1. 2 pi. 2 pi divided by 2, pi. Sine of pi is 0. 3 pi. 3 pi divided by 2, 3 pi over 2. Sine of 3 pi over 2 is -1. And then 4 pi divided by 2 is 2 pi. Sine of 2 pi is back to 0. Okay, and so there's the graph. Okay. Now, compare that to a normal sine graph. Okay.
We should keep the graph. We should keep the line the same, just change the things on the graph.
Yeah, you can do that if you want. Yeah, it's really about the amount of the scale. Now, I'll just graph sine of x up there real quick because sine of x is easy to graph, with what we've got because it goes from 0 to 2 pi. So sine of x, it would also include then pi over 2 and 3 pi over 2. Okay, and so then sine would look something like this. Okay, so there's one full period of sine. So you can see how the sine, right, is kind of compressed in from that sine of x over 2, or vice versa. The sine of x over 2 is stretched out twice as long as the graph of sine of x. You can fit, 2 sine of x's here in the same length that it takes for just one full graph, one full period of the sine of x over 2. Okay. So you can see 2 full periods. 1, 2 fits in just the one full period there. Okay. Questions on any of that? Questions on any of that? Okay. So the graphs I'm going to give you guys here now for your assignment, they're going to have just amplitude, just period, shift, or there could be a combination of both there too. Okay. So there it is. All right. I'll get you guys here started on that. Here's your assignment. All right. If I have, where did I put that? Oh, there. All right. So on page 326, we have you do numbers 5 to 13, 27, 31, 41, 43, 47, and 87, and those are odd for the 5 to 13. Okay. So there is your assignment.